Next, we have about the chapter current electricity. Okay, let's discuss the main points in the chapter current electricity, which is useful for the learning the numericals and or practicing of numericals in application level questions. Okay, let's begin the basic concepts of current electricity. Basic concepts in the sense I'm mentioning about the basic equations. Okay, we know the equation for the drift velocity. That's one equation we have to know. Minus E by m into tau, where tau is the relaxation time. It's the time interval between two successive collisions of electron with atoms on the way. E is the electric field intensity. Another equation we have is the current flowing through a conductor of cross section A. I is equal to NEAVD. Remember, N is the number of free electrons per unit volume, otherwise free electron density. A is the area of cross section, and VD is the drift velocity. We have another concept about the relation between drift velocity and electric field, which is nothing but mu E, where mu is called what? Mobility. Mu is the mobility. We have the concept of Ohm's law. All of you are okay with that. V by I is equal to R, where R is the resistance. Resistance is a constant which is dependent on these factors: resistivity, otherwise specific resistance, length, and area of cross section. Okay, but resistivity in turn depends only on these factors: m by Ne squared tau. See, memorize this equation as well. Resistivity depends on the number density of free electrons, that is small n, and relaxation time. By the way, relaxation time in turn depends on the temperature. As temperature increases, relaxation time will decrease. The collisions will become more frequent, and I'm talking about the conductor. Okay, so that means the two factors on which resistivity depends are the number density. In turn, it depends on the nature of substance, and the temperature. In turn, depending upon the temperature, relaxation time will change. So, in general, resistance of a conductor depends on the nature, the temperature, the length and area of cross section of the material. Okay, and resistor, the resistors can be connected. Resistor means nothing but a wire which is of high resistivity. It can be used to control current in a circuit. Okay, so when resistors are connected, they can be connected in series and parallel. Series connection, we know that resistors when connected in series, R1, R2, R3 are the resistors in series. Okay, there we have like series resistances R1 plus, R2 plus, R3 like that. Whereas in the case of parallel combination, in parallel combination what happens is they are connected in this way. Okay, that is like what we said about capacitors. Here also we can say the effective resistance here in the case of series combination, effective resistance will become high. It will increase. Why it increases? That's nothing but because the overall length increases. Resistance is directly proportional to length. Therefore, total resistance will increase. Whereas in the case of parallel combination, what's happening is overall resistance will decrease. You know that equation is given by 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 like that. So overall resistance will decrease. That is nothing but because when resistors are connected in parallel, the overall area of cross section will increase. You know that area of cross section and resistance, they are inversely proportional. That's why the effective resistance decreases in parallel combination. Area increases, resistance decreases. Okay, now on what factors resistance depends? I said about certain factors like length, area of cross section, nature, temperature and all. So when you look at the temperature thing, we get there is an equation R2 is equal to R1 into 1 plus alpha into T2 minus T1, where R1 is the resistance of the wire at T1 and R2 is the resistance of the wire at T2 degrees Celsius, or it can be in Kelvin also because the temperature is difference in temperature. And alpha is a quantity which is described as which is termed as the temperature coefficient of resistance, temperature coefficient of resistance or temperature coefficient of resistivity, which is nothing but how much is the up to what extent the resistance of the substance will vary with respect to changes in temperature. There we might have studied one point, that is about alloys. It has got low value of temperature coefficients. So what happens is, because of the temperature coefficient resistance value is low, its resistance will not be considerably affected by the changes in temperature. So it is suitable to make standard resistors in the laboratory. We have studied that. Okay, resistance is varying like this. This is the equation to memorize there. Okay, so that's about Ohm's law, resistances. Then we have another concept to think about, that is combination of cells. In fact, this year in this term we have three kinds of combinations to learn. One is combination of resistors, second combination of capacitors, then combination of cells. Cells can be combined like this. For a cell of EMF E and internal resistance R, like that, so many cells can be connected. Okay, when cells are connected in series in this way, the effective or equivalent EMF of the cell of the combination would be, this is, I'm talking about series combination of cells, E1 plus E2 plus E3, just like resistors. And even equivalent resistance also can be calculated by using the equation R1 plus R2. That's again when resistors connected in series, same thing. Okay, so that's the case. This is the case of combination of cells in series. So it shows that whenever cells are connected in series, the overall EMF is increasing. Even overall internal resistance also is increasing. One thing to be clear about this is, let me explain that here. That is, when cells are connected, as far as one single cell is concerned, when connected in an external circuit or with an external circuit of resistance R, you see one cell of internal resistance R, and when it is connected across the external resistance capital R, then the current in the equation is E by R plus R. E by R plus R is the total current in the equation. And also the terminal potential difference would be E minus V is equal to E minus IR. These are the two equations to memorize as far as the given cell is concerned. Okay, and be clear, in between I was telling about this, that is, whenever internal resistance is increasing, current will decrease. But if EMF is increasing, current will increase. Okay, so that way when you connect cells in series, the thing is that effective EMF increases, so current will also increase. But at the same time, effective internal resistance also increases. That is not good. Current will decrease now. But the more influence is for the EMF, because internal resistance is normally very low. So negligible effect only will be there in the addition of the internal resistances, especially when you buy, in the case of new cells. Okay, but when we talk about parallel combination, cells are connected like this. One, two, like that. Cells are connected in this way. This is parallel combination. So if the cells have EMFs E1 and E2, internal resistance R1 and R2, then what happens is the effective EMF, that is equivalent EMF, is calculated using the equation E1 R2 plus E2 R1 the whole by R1 plus R2. E1 R2 plus E2 R1 by the whole by R1 plus R2 is the equation which we have for the two cells connected. Equivalent EMF when two cells are connected in parallel. Whereas equivalent internal resistance is R1 R2 by R1 plus R2. This is equivalent internal resistance. So effective EMF, effective or equivalent internal resistance also. But if many cells are connected in parallel, there is an equation to memorize for many cells when connected in parallel. The corresponding equation is, memorize this equation, E equivalent by R equivalent is equal to E1 by R1 plus E2 by R2 plus E3 by R3. Sorry, like that it is. But an important aspect to understand is, even if many cells are connected, many identical cells are connected in parallel, suppose for example 1.5 volt is the EMF of one cells, like that 10 cells you are connecting in parallel. Remember, the overall EMF will be only 1.5 volt. That is, even if many cells are connected in parallel, many identical cells are connected in parallel, the overall EMF will only be that of one single cell. But the advantage of this is, like, two advantages there in parallel combination. One is so many hours you can, or the time duration which you can deliver current, it can deliver current to the external circuit will be long. That is, if suppose a device which you are going to use continuously for a long time, you can use parallel combination of cells. Also the internal resistance, if suppose it is the cells have got appreciable internal resistances. So what happens is, by connecting the cells in parallel, the overall internal resistance will be reduced. Parallel combination of resistance, internal resistance will be reduced now. So overall internal resistance, if we can reduce, that way current will become significant. Okay, so if cells have got some what is a considerable internal resistances, you can think of connecting them in parallel. Otherwise, the current, you will not get a sufficient current if they are connected in series. Okay. Also, if suppose internal resistance is low, but you want to use cells for a longer duration, then it is better to use parallel combination, so that it can be used for a longer time. Okay, it will deliver current for a longer time. That's about combination of cells. Now, the next point to understand is about electric power and electric energy, and certain equations to memorize. Three equations I'll tell you. Power is VI, power is V squared by R is another equation, and electric power is I squared R. Okay. To all the equations, if you multiply it with time, you will get the corresponding equation for electrical energy. Okay, so this is what is something which you can connect with the electrical appliances and fuses and things like that, heating devices. Okay, whenever you are thinking of an electrical device which is used for household purposes, remember all the household devices are connected in parallel. So what happens is, in parallel combination, voltage is the same. So think of the equation P is equal to V squared by R, because V can be kept the same for the devices or for the appliances which we are using for the household purposes. Okay, and along with one more thing I want to tell you is, in the case of any circuit, the cell, if it is delivering a power, the power power delivered by a cell is maximum, when power is maximum, when external and internal resistances are equal. This is something to remember. When external resistance is equal to internal resistance, the power delivered by the source is always maximum. Okay, that time what will be the current? We know that the current is I is equal to E by R plus R. So if you put capital R as in the place of capital R, if you write small letter r, then the equation for current will become E by small r plus small r, that is E by 2R. What is this equation for? Equation for the current from a cell when it delivers maximum power. So current when it delivers maximum power is I is equal to E by 2R. It's okay. That is one thing. And I mentioned about the current coming from a cell. And also another thing, last one more point before we move on to the next topic, is whenever cells are charging, or there are secondary cells, when there are cells which can be recharged. As far as the charging of cells concerned, memorize these equations. One is current is E dash minus E by R plus R. You know what is E dash? See, just imagine this is the EMF of the cell to be recharged, and recharging is being done by a big source of EMF E dash. So E and E dash may be a resistance here. Then the equation for current is given by this equation. E dash is the big source. For example, this is maybe 100 volt and this is maybe 10 volt, like that. So 10 volt battery is to be recharged by using a source of 100 volt. Okay, then we can use this equation. And another thing is the terminal potential difference, which is E plus IR. So this is equation for current, this is equation for terminal potential difference from the charging battery. So there is a question like, can the terminal voltage be greater than the EMF in any case? This is a situation where the terminal voltage is greater than EMF, that is during charging of a cell, terminal voltage is greater than the EMF. Okay. Then finally we have the terms like Kirchhoff's rules. Memorize the two rules. First rule is what? The junction rule. Second rule is the loop rule. Okay, junction rule is always also referred to as the outcome of the conservation of charge, whereas loop rule is the outcome of conservation of energy. They are applied in Wheatstone's principle. Kirchhoff's rules applied in Wheatstone's principle, which is nothing but if there are resistors connected in the form of a bridge like this, and a galvanometer along with the battery, the resistors P, Q, R and S, if there are, then when it is balancing, that is when the galvanometer shows zero deflection, that is when there is no current, the bridge is balanced, that time P by Q is equal to R by S. This is called Wheatstone's principle. This Wheatstone's principle is made use of in meter bridge. Okay, in meter bridge, the equation we have for finding the unknown resistance is R into L by 100 minus L. This is the equation to use. When if the resistance which or the known resistance is connected in the left gap and the unknown resistance is connected in the right gap. Actually, over there, this is a 1 meter wire AB of length 1 meter. So the balance length you are getting is maybe here. So in fact, this R by X is equal to L by 100 minus L. So X is equal to, the equation here, what is the equation I have written is in such a way that it is connected the other way. Be clear, this is the unknown resistance, that is X, okay, to be determined, and this is the known resistance, that is R. This is a place where we connect galvanometer, jockey, and of course there is battery and all. Okay, it's the case of meter bridge concept, you should know. So this is the point. One second. Sorry, X is equal to R into L by 100 minus L is the equation to use. So basically what you should do is just memorize Wheatstone's principle, and based on this you can say X by R, this by this, this by this is equal to L by 100 minus L. Actually L by 100 minus L, when you say ratio of resistance only, because suppose K is the resistance per centimeter, you can say KL by K into 100 minus L, like that you can write K will cancel. This is what is leading to the equation X is equal to R into L by 100 minus L. So that's the equation which you want to memorize for meter bridge. And finally, the concept of potentiometer is a really important concept. In potentiometer, the basic principle is the potential difference is proportional to the length of the wire under constant current. But in potentiometer, we know that in potentiometer, the whole wire AB is connected to the battery, the rheostat, key and all. Okay, this is a primary circuit, and we have here the secondary circuit. Okay, galvanometer and connected to jockey. You may connect a high resistance here if you want, like that also it's possible. That is to protect the device. Means it's a high sensitive, galvanometer is a highly sensitive device. So here we will write if L is a balance length you are getting, which shows the galvanometer has the zero deflection, then we can also say E proportional to L. So using this, we have two things to learn. One is about the comparison of EMFs. E1 by E2 is equal to L1 by L2. That is by just calculating the balance in lengths with the help of two cells. One you connect at the beginning and find the balance length. Then remove this and connect E2. Again find the balance length. That is L2. So E1 by E2 is equal to L1 by L2 is one equation to memorize. Another thing to learn from this is you are connecting a high resistance or resistance value in parallel to this cell or across a cell, so that we can determine the internal resistance of this cell. So internal resistance of this cell can be calculated using this equation. R is equal to R into L by L2 minus L. L1 by L2 minus L1. That is the equation for the internal resistance. Let me make it clear. I think we can get it. That is, if suppose, one second please, using the first cell, okay, E proportional to L1. Suppose we keep the key open and finding the balance length. This is what we get initially. And when you're connecting this cell, the resistance across it, then it becomes the potential difference. Means potential difference across the resistance R, that is proportional to the balance length L2, new balance length. Okay, so there what you can write is, instead of potential difference you can write current into resistance proportional to L2. Current is E by R plus R proportional to L2. So if you divide equation 2 by 1, what do we get is R by R plus R is equal to L2 by L1. This on cross multiplying we get what? RL1 is equal to capital RL2 plus small rl2. Okay, I was trying to get it for you. Small r is equal to, what you get is R into, this comes like this, R into L1 minus L2 by L2. Okay, sorry, This is the way the equation is. So, to determine the internal resistance of a cell, what you should do is first, without the external resistance R, you find a balance length, that is L1. Then include a resistance, non-resistance, maybe 2 ohm or something. Then find out the balance length is L2. Then use this equation to calculate the internal resistance. So, dear children, very first thing to learn is the basic idea about the mechanism of the electric current flow through a conductor. I am talking about the chapter current electricity. Then Ohm's law, factors affecting resistance. Then what is the variation of resistance with temperature. Then power, electrical energy equations. These two areas sometimes we may take it light. One is about the power, energy, and heating devices and things like that. Also, we have some concepts related to the charging of a cell. That's another area where you have to practice. Then obviously the Kirchhoff's rules, meter, bridge, potentiometer, all of you would be doing a lot of questions related to that. Okay. So anyway, again, let me tell you, I've just presented one video which is to explain the basic concepts of electromagnetic induction and AC, and I've done with the first two chapters electrostatics, and now this is for current electricity. These are the chapters for the first term, and one more is their magnetic effects and magnetism. That is fourth and fifth chapters that will be explained in the next video. Okay, so this is just to brush up the concepts just before the examination. Okay, thank you.